Hi, everyone. Welcome to Getting Started with the Micronaut Framework. My name is Sergio del Amo. I am from Spain. I work at a company called Object Computing, who is based in the States, in St. Louis. We have been the company behind the development of Micronaut since its inception. And I work there as a Micronaut development lead. You can find me either on my website or in Twitter. I want to talk to you about Micronaut. Who has heard of Micronaut here before? I probably don't see your hands. So really few people. So that's sad to hear. It's probably good news for the talk, but sad to hear. So Micronaut is a JVM framework, a license under Apache 2, so no strings attached. We have follow a semantic version. We have a major version where breaking changes are introduced almost every year. Minor versions where new features are introduced every more or less 6 weeks. Patch versions every week or so. We are closely approaching Micronaut 4, which will be released by the end of this year, probably third quarter. So the framework is already used in production by many companies. It's already, we released actually Micronaut 1.0 back in 2018, pre-COVID times. So it is a framework ready for productions. You can write Micronaut applications with either Java, Groovy, or Kotlin. We still support Java 8, and we support JDK 17 with the new features you can use, for example, records as mapped entities if you are using something like Micronaut data for persistence, or you can use records as the objects being serialized in your REST API as well. We support both Gradle and Maven. You don't have to use our build plugins, but we do offer both Gradle and Maven plugins. What the build plugins gives you is kind of a streamlined developer experience. We, for example, give you both Gradle tasks or Maven goals to generate easily GraalVM native images. But as I said, it's completely optional. We are also test framework agnostic. You can test your Micronaut applications using JUnit 5. You can use Spock, or you can use code test if you are you want to use a Kotlin testing framework. We will have support for code test version 5 in the next minor of Micronaut. We have a community contribution who added support for that. We are also reactive library agnostic. You can all of our APIs, they don't expose, they only expose the reactive streams. So you have publisher when we have like reactive APIs. Internally, the modules use Project Reactor, but we have support for RxJava 2 and RxJava 3. Actually, Micronaut started using internally RxJava 2, but we transitioned to Project Reactor in Micronaut 3. We are also cloud agnostic. You can, and we have many features to work with different cloud vendors. We support the 4 major cloud vendors, AWS, Google Cloud, Azure Functions, or Oracle Cloud. We have a really interesting story in serverless. You can write Micronaut applications and deploy them to AWS Lambda or to Azure Functions or to Google Cloud Functions. We also support interesting things such as generating a GraalVM native image really easily of your function so that you are able to overcome the problems with cold startup in serverless scenarios such as Lambda. More or less at the time that Micronaut was being developed back in 2018, Oracle Labs released GraalVM, which is a polyglot virtual machine, but one of the components which is really popular between Java developers is the ability of GraalVM to generate a native image of your application. You can use reflection with GraalVM, but if you use reflection, you have to essentially kind of whitelist it. So Micronaut was from the beginning like a matchmaking heaven for GraalVM because Micronaut is like doesn't use reflection at all. We avoid reflection like it's a plague. So one of the philosophies of Micronaut is do as much as you can as build time instead of runtime. So since the beginning, Micronaut has played really well with GraalVM, and we continue to do so. In fact, there is a team at Oracle who is developing Micronaut as well, and they work head-to-head with GraalVM. We have a huge battery of functional tests testing the integration. So if you want to, if you have heard about GraalVM and you want to generate native images of your applications, check it out, because I think you will like what we have to offer. By default, a Micronaut application will use the native runtime, but we have support also for if you need to deploy as a WAR file, for example, you can use integration with Tomcat or with Jetty or with Undertow. So we have support for servlet, kind of following the philosophy of being runtime agnostic. The default is netty, and that's where probably what I would recommend you to use if you can. But you have other options as well. And its core, we like to say that Micronaut is a foundation framework. And at its core, Micronaut is a dependency injection engine. We have also, on top of that, the things that you expect as a developer. So we allow you to inject configuration. I'm going to show you in a demo. We also have, we implement a subset of bin validation specification as well. We have a great support for building AOP. So that typical thing that you will use annotations, for example, around a method. Think of a transactional. And the framework also ships with a great HTTP client. So when you are working with Micronaut, you don't need to have like a retrofit or a volley or something like that. Micronaut ships with a great HTTP client, which is based on NetIO. You can have Micronaut applications configured with YAML, which is the default, but we also support properties files, TAMLs in Micronaut 3.4, and Groovy and config4j. I'm going to show you a Micronaut application. So hopefully, the home of Micronaut is Micronaut.io. And to create a Micronaut application, we have both a web interface, which we call Micronaut Launch. So you go to launch.micronaut.io, you will visit this page. You essentially choose your poison. You select the language, you select the build tool, you select the test framework, and then we have like features which you can add. Essentially, that will modify your build file. I'm going to start fresh. So the idea is that you will come here and you go here and do your GeeCON and you generate a project, and this will download a zip file to your computer. You can just drag and drop this file and import it into IntelliJ. We have great integration with IntelliJ or with Visual Studio Code. I have actually already like unzipped the file and imported it into IntelliJ so that we don't lose the time on resolving dependencies. So let me show you how you can work with Micronaut. How do you create a REST API? So you essentially can use a set of annotations that we have to create controllers, or we even have support for JAX-RS if you want to use the JAX-RS annotations as well. So you can create a controller. As you can imagine, the annotation is quite intuitive. It's called controller. We have annotations for the different HTTP verbs. So I can use here a get, and can say this is string. You can use path variables. This is going to be my name. I'm going to say this is not going to be JSON for now. It's going to be just a string. So I'm going to say this produces media type, text plain, and I can return like hello and the name. Not too original, I know. And if I run the application, you see that the application starts quite fast, starting in half a second. I can do here a call command. I can do localhost 8080 Sergio. And hopefully you saw the hello Sergio there being output. I think there is -s. Micronaut is really science when you test. So let me create a test. As I said, you can use different test frameworks. I'm going to use JUnit here in this demo. So I can do here a test, and let's say test API. And in Micronaut, you start a real server. You don't start a mock server, because the application starts so fast that you can start a real server. So I'm going to say here embedded server, application context, run embedded server. Class. I'm gonna make room. I'm going to close the server because I am a good citizen at the end of my test, and I'm going to create an HTTP client. This is the HTTP client that I told you that my code ships with. It's an optional dependency. And I'm going to point the HTTP client to my server that I just started. The HTTP client by default will return publishers. And since I am testing, I'm probably not interested in publishers. So what I'm going to do is I'm going to get a blocking HTTP client, which is typically the client that you will use in your test. For sending requests, we have a great Fluid API. So this will be like get. And I can do something like, I can just write here the URL directly. And I can say, I want the body to be bound to a string. And typically, when you work with an HTTP client, you either work with HTTP with exchange, which is the method which will give you the whole HTTP response envelope. So in my test, I can test that I can assert here, or assert equals, sorry, because this is a unit. And I can do here HTTP status OK. That's 200. And I can check that there is like a 200 OK. I can check that the body is present, and that should be in JUnit parlance assert true, because the body is an optional by default. And now I can do an assert equals, and I can do response get body, get, and what I am expecting to see is hello, Sergio. So I'm going to just run the test. Hopefully it passes. And just to demonstrate that this is a real server and a client happening, I'm going to go by default. We use logback for logging by default. So I'm going to log actually the package of the HTTP client. If I remember my shortcut incantation. And you will see in the logs in the request being issued and received. So if I rerun the test, we should see here the HTTP request being received and the response being created. So a real thing, not a mock HTTP client. If you have worked with a framework such as Spring Boot, you are probably used to an annotation for tests. We do have that annotation. I just wanted to show you what the annotation is going to do for you. So we have a micro test annotation, which essentially will start the server. And then I can do here, I can inject here a client, which will be already pointing to my server. And the test should still pass. Let me just make this small. So we have a micro test annotation. Micro test annotation has what you can expect. So you can either run just the DI context or the whole server, including the DI context. You can wraps everything with in a transaction by default. You can disable that if you don't want. You can have like different environments. So what you can think about in a transaction. We have a great thing as well. So I just showed you what we typically refer to as the manual HTTP client, which is kind of our low-level client. We have the ability also of declaring an interface. So you have worked with retrofit. Some of you have done your time in the Android world. You may have. You can create a greeting client here, and you can annotate with client. Our client supports like service discovery, so you can have like a client ID here and just using the simple thing that is pointing. You can define an interface. A Micronaut at build time will implement this interface for you. So I can say this is going to be a GET request. I'm going to say consumes media type plain text. That means that when the client issues a request, it's going to add that it accepts. In the accept HTTP header, it accepts text plain. And then I can do here index, and I can do the similar incantation as I did in the server. And I can do here name. and string. This is my interface. So now instead of using the low-level client, or in addition to using the low-level client, I could come here to my test and add inject my client. And here I could do here a greeting client. I call it index, but you could call it whatever. So this will be Sergio. And what I expect to happen, let me actually extract here a variable. And what we are expecting is that this thing already returns like a string. So I can check that this thing is actually doing this. So the HTTP client, the declarative one, is going to do the same thing. So let me just run the test again. And I minimized it so much, but if you saw the pop-up there in the bottom, it passed the test. So that's what we typically call declarative HTTP clients. The idea here is you create an interface, and at build time, Micronaut will implement the interface for you. Really, really powerful. Bin introspection. So what I have shown you is a hello world example where we are responding just a string. So things get more interesting when we respond JSON. So let me actually create a class, a Pollo, the typical Pollo that you will have. I'm going to do here private final string message. And I'm going to say this is going to be not blank. I'm going to annotate this class with that introspected, and I'm going to do the typical I like to use also the non-null annotation for our Kotlin friends. So I'm going to do like just a getter. I'm going to respond here greeting. Micronaut, being like a modern framework, we respond JSON by default. So if you are responding JSON, you don't have to specify the media type. And now I can do here new greeting. I think in the constructor we pass the message. And now I will have to change my client. I can remove the consumes, add here a greeting, Pollo. In the test, I'm going to have here a greeting. This is going to be greeting get message. And this is, instead of class, I'm going to say map it to a greeting. Map it to a greeting. And this is going to be like this. Let me just run the test again. And hopefully, the test will pass again. Let me show you the logs, and hopefully we'll be able to see like there is JSON being generated in the server side. So, really easy to have a Pollo serialized into JSON. Micronaut uses Jackson by default to serialize, so you can use the Jackson annotations. We actually have a quite interesting project called Micronaut Serialization, which we have created a replacement for Jackson data bind, which using no reflection at all, to do serialization and deserialization from JSON. And also we support also JSON-P and Bison. So we are quite excited about that project, and I think that's going to open a lot of possibilities. By default, we are still generating applications with Jackson, and we will support Jackson in Micronaut 4, so you will be able to choose whether to use Jackson serialization with the Jackson annotation, so you can use your JSON property, your JSON include, all of those things you are used to. But you could use our implementation instead of Jackson data bind, which is also like a smaller jar. So that will be important in serverless scenarios, or scenarios where you want to have an application as slim as possible. One thing that I didn't tell you before I forget is, note that introspective annotation that I added that there. With that annotation, Micronaut at build time will generate meta information of this class. And this allows us to validate this class and also to instantiate this class without usage reflection. So we have like an API called bin introspection, and allows us to instantiate this class with a usage reflection, which is used also for serialization scenarios, but also for a scenario, for example, like, I don't know, you are uploading a CSV file to your server and you want for each row in the CSV file to instantiate a Java object and populate it with the CSV file, you can do that without reflection in Micronaut. There you go. So I wanted to show you, I told you in the beginning that we are like a dependency injection framework, a dependency engine. So let me create a service called greeting service. It's going to be an interface. I'm going to say greeting, hello, string name. You can use validation annotations. I'm going to say name cannot be blank. And I'm going to say here, greeting is going to be not null. And I can create an implementation of this interface. And as you can imagine, to define a singleton in Micronaut, you use at singleton the Jakarta notation. So this is not a proprietary Micronaut application, but the Jakarta one. I'm going to implement it, and I'm going to move the logic that I had in the controller. So I'm going to move here the logic. So you have several options to inject a bin of type greeting service in the controller. The one that we typically recommend when you can is to use constructor injection. So you come here and you do greeting service, and IntelliJ actually will generate the constructor for me. So this allows us to have like greeting service private. So let me just use the service and see if the test is still green. You can use, you can use also field injection. So I could use here at inject. And that should work as well. Or you could use setter injection, which will work as well. So we support the three. When possible, we recommend you to use constructor injection. That's what I will be doing. When you don't instantiate the class, such as in the test, then field injection comes to rescue. So you saw in the test that I was using at inject with the HTTP client. But that's dependency injection in a nutshell. Let me go back to constructor injection. And let me show you something, which is we have the ability also to inject configuration, similar to what you are using in other frameworks. We are there as well. So if you do here and you say GeeCON prefix, something like that, and say hello, I can create a Java object to essentially load that configuration, to inject that configuration. So let me create GeeCON. So we support this to be an interface or a class. Let me create an interface backed by a class, just to be a bit pedant. Get prefix. And I'm going to create here a bin of type GeeCON configuration, which is going to be this one, GeeCON configuration. I'm going to create here private string prefix. I could, by default, the bin will be loaded only on demand, but you can annotate it without context if you want like configuration to be validated on a startup. And this will be not a singleton, but a configuration property, which is actually a singleton as well. And the prefix that we used was GeeCON. So now I can come and inject this, a bin of type GeeCON configuration in my service. So I could come here and do private final GeeCON configuration back to the idea of using constructor injection. I am using constructor injection here in the service. And I can come here and I could do here GeeCON configuration get prefix. And if I didn't make a mistake, which I probably did, the test should still be green. So we support annotations such as @property. We support annotations such as @value if you want to inject, or my preferred annotation, which is @configuration property, so that you can inject configuration into your Java objects. We support also an annotation called each property, where you can drive configuration. So that's when you typically have like, you could have multiple instances of a particular configuration. Think if your application supports multiple databases, you will have like configuration for each of the database. So we have an annotation called each property as well. Validation. I told you that we support validation, so let me show you that is for real. So I could use the JavaX validation constraints. So I could come here and say, this is a pattern, and this allows a regular expression, and I can say, name has to be Sergio, because I have such an ego, or if I am able to write the pipe character, which apparently I am not. Okay, let me just say it can only be Sergio. I was trying to write a regular expression, but without much success. So if I run this now, the test still passes, because in the test I was using Sergio. Let me run the application and show you. I run the app. Pretty fast, 368 milliseconds. I'm going to say Sergio, OK. I'm going to say -I, so that we see the response code, 200 OK. I'm going to say team. And you see bad request. And you saw, by default, my code uses to render errors. We use BND error, which is kind of a standard. We also support problem JSON, which is my preferred way to render errors. And we have quite an open API. So if your company needs to render errors in a particular way, you have a really nice API to extend that. You handle errors using exception handlers. You can also use like global error handlers in controllers or in a controller method as well. But we have quite a good integration for different kind of mapping the errors. You see here that actually it failed because of the constraint that we just added. How can we test that in the test? Micronaut HTTP client will throw an, when you do a request and the server responds something that is not in the 200 or 300 range, so when it sends a 400 range or a 500, it will throw an exception called HTTP client response exception. So let me show that to you. So if I come here, I do have here the incantation to capture an exception in JUnit 5. So if instead of using Sergio, I use here team, and this is the Spring, the JUnit 1, I can get the exception here, and I can actually verify that this is 400 or HTTP status bad request, not bad gateway, but bad request, which is 400 bad request. And let me run the test and see if the test is still green. So when you work with exceptions, how you handle them with an Micronaut HTTP client, you just capture the HTTP client response exception. And the HTTP client response exception, you have access as well to the body of the response. So there is a response which will give you the HTTP response. Let me show you more things. We have also great support to generate. So when you work with an API, more or less a standard has emerged that OpenAPI is which is the successor of Swagger 2. It's kind of the standard, more or less, specification to describe an API. And we have a great support for generating an OpenAPI specification of your project at build time. So let me show you that to you. So in order to do that, Micronaut does most of its logic using annotation processors. So I'm going to have to standard Java annotation processors. So I'm going to have to add one. So I'm going to add here OpenAPI build. So I'm going to add the Micronaut OpenAPI annotation processor, and I'm going to add also the Swagger annotations. So we support the official Swagger annotations. So by default, we will try to generate a specification as close as possible, but sometimes you have to Swagger has nice annotations where you can, for example, in field of classes, you can use add schema and describe what actually this thing is for the API. So we support that. So I need this in place, and typically then in your application class or in another class, you use here OpenAPI. You annotate your application class, and you give the demo the name of your API. So now, let me show you that if I do classes, which will essentially compile my project in Gradle, this is going to generate at build time. It actually told me there. It generated a demo.yaml file. So at build time, it generates here in my build folder, classes, main, metainf, swagger, demo. The demo is because in my application class, I call it demo. It essentially generates a specification of my application. So I have one path, the path of the controller. It tells me that I have a path parameter, which is required. It tells that I am responding 200 OK and with this object. And here it defines the schema of the object. So out of the box, as you saw, you just add a build dependencies, and at compilation, we generate the specification. We have also integration to visualize this in a UI. So there are several projects which allow you to essentially, from a YAML OpenAPI specification, generate like a visual representation. We have integration with Swagger UI. We have integration with RapidDoc and with someone else, which unfortunately I'm forgetting. So we have integration with 3 such visualization tools. So it's really easy to directly expose in your application an HTML of this representation. But the important thing that for me is that this file is generating, because this is the real specification. Swagger UI is a visualization on top of this. I wanted to show you another thing that we have is we have quite an exciting persistence story. I'm going to integrate Micronaut data JDBC into this application. So I'm going to go here to my build file, and I'm going to add a bunch of dependencies. So again, Micronaut does a lot of things at build time. So I'm going to add the Micronaut data annotation processor. I'm going to add also the Micronaut data JDBC dependency. I'm going to add Flyway. We have great support for both Flyway and Liquibase to generate the database schema of your application. I have added Hikari for the connection pool, and I have added MySQL. We are quite opinionated about allowing users and try to enforce that people use the same database that they use in production in their test. So I have here MySQL, and I have here also MySQL test containers, which will essentially allow us to run a MySQL database in a Docker container directly in our test. These dependencies that I just added are the same dependencies that you will get in your build file if you selected data, JDBC, MySQL, and Flyway in your dependencies. So I'm going to go to configuration. I'm going to go here to application.yaml. I'm going to add here configuration to access my database. This is an example of something that you could have multiple of. So I have only one database, which is the default, but you could have many. And as you may imagine, you define the JDBC URL, username, password, the dialect, and the driver. Then I have to add also configuration for Flyway. So I'm going to add here I'm going to enable Flyway as well. And I'm going to create the database schema with Flyway, which is going to be under resources, DB migrations. We support Liquibase as well. And here, Flyway has this funny naming convention. So I'm going to create a database with just one table, which is going to call message, and I'm going to insert a message into the table. Let's say here GeeCON instead. I'm going to go to create the entity. We support also with microdata. You can use microdata JDBC, microdata JPA with Hibernate, and microdata with MongoDB since Micro 3.4 actually, which we are quite excited. So I am using microdata JDBC. I'm going to create here an entity. I'm going to call it message. You can annotate this with mapped entity, and by default, it's going to use this class name, which is going to match my message table name, so that's going to be fine. I can use ID, because it's going to be the primary key, and this is going to be generated value. You have to do. Let me add also the name, getters and setters. I can say, for example, that the name is required using the standards. It's going to be probably not blank. JavaX constraints annotations. And then the interesting thing is I can come here and I do a message repository, an interface. I can extend from CRUD repository. CRUD repository takes two generics. One is going to be my entity, so in this example message, and the primary key. And CRUD repository is going to have find all, count, find by, the method that you may expect. I can come now to this is going to be annotated with JDBC repository, and here you have to specify a dialect, and the dialect in my case is going to be MySQL. So we have an interface which is going to be implemented at compilation time. I can inject this interface here as well, private final, message repository. And I can do here hello, probably from message repository. Let me do something which is, let me do a Postman solution. I'm going to do here message repository. I think find all by default returns uniterable. Should probably use the stream API, but hopefully you get the idea. And if not, let's do this. So to start a database in the test container has a great thing called, Micronaut supports those environments, so I can have here a application does test, and by default the tests, they will run in the test environment. So I could be here and do, and this adds this magic JDBC URL, which a test container will use essentially to create a database in my test. And I am probably forgetting something, but in theory we should be able to run the test. It's failed because I have not changed it, but let me see if I have forgotten anything. So what's going to happen right now is the application is going to start, test container is going to start a MySQL database. We are going to run a Flyway schema migration to create a schema, an insert, and then we are going to do a select all from message, and the test hopefully is going to fail because it's going to tell you are expecting hello Sergio, and the test is hello from GeeCON Sergio. the demo god seems not to be with me. Okay, test fail. Let me see where it failed. It says query table test message. This does not exist. Let me see. DB migrations, DB migrations. I have misconfigured something, but let me show you. I lost the window. Is incorrect, schema? I think this should be fine. So we stick it with flyaway with their weird underscore underscore. Let me see. The query table. I think the migrations are being run correctly. Let me just do something, which is bring my project and show you, and see if I actually DB migration singular. That's a good gotcha. Let me see if that's actually get us there. So the idea is that this should run the flyway migration, which we are not seeing. So when the Micronaut data was trying to query the database, the table didn't exist because flyway migration never ran. Okay. Failure, failure, failure. But the failure is nicer now. So it's failing because I didn't update in my test. I wanted to see it fail. So let me just update my test. The test should be green. So we are essentially connecting to the database. So as you saw, it's pretty simple to use Micronaut data. We do a lot of logic at build time. Micronaut data JDBC is really, really exciting. It's really, really fast. It's gets a lot of the joy of working with SQL back. And testing together with test containers is also like quite a powerful thing. Now that my test run, I'm gonna show you how you will generate a native image. And I'm gonna go through some slides because generating a native image. So what I told in the beginning is that our official build plugins, they have commands to generate a native image. So I could come here and select. So I have this tool called SDK Man, which allows me to have multiple JDK versions installed. GraalVM distributes the GraalVM version. So I have this one installed. So what I'm going to do is I'm going to use the GraalVM JDK. So I'm going to use the GraalVM JDK. So if I do here Java version without a typo, you should see that I am using GraalVM. And now I could come here and do native compile. And this will generate the native image of my application. This is a MacBook Air running Rosetta, so it's not going to generate an optimized native image because this is an ARM architecture, and with Rosetta it's trying to like generate for Intel. So let me, while this generates, but as you see, it's just one step to generate a native image. Really nice to try. If you run this in an Intel machine, you will see like millisecond startup time and an amazing low memory consumption. So GraalVM is quite exciting, and it's really easy to test with Micronaut. Let me go back to my slides while the GraalVM generates. And let me just go fast, quick. I only have 3 minutes. We have great story for messaging. We allow you to, we support, we have a vibrant Kafka community. You can have, for example, a Micronaut application without even an HTTP server being a pure Kafka consumer. We have a great integration as well with RabbitMQ, with MQTT, with NATS. As I showed you in the demo, we have integration with database migration tools. We have integrations with Flyway and Wikibase. We have a great persistent story. We have microdata, which is kind of our favorite child, but we have integration as well with Redis, GORM, Neo4j. We have another integration with Juke as well. You can use microdata. I showed you in the demo with microdata JDBC. You can use with Hibernate, JPA, and with MongoDB as well. See, my clicker works. This is things that I am really excited about. You still can, so Micronaut is a foundation framework. You can build microservices, but if you don't want to, and for many scenarios you probably don't need to, if you want to write a monolith and you want to render server-side HTML or server-side templates for emails or things like that, we have great support for service-side view rendering. We have integration with JT, Thymeleaf, Handlebars, Pebble, Rocker, which is the one which we use, for example, in Micronaut Launch, Soy, and in Micronaut 3.5, we are going to debut integration with Turbo, which is a component from Hotwire, which will allow you to essentially kind of create backends server in HTML with the same speeds that you will typically gain with a single-page application using front-end JavaScript frameworks. We have a great security story. We support basic authentication, JSON-based authentication, multiple LDAP servers. We have support in your Micronaut applications to generate JWTs, sign them, validate remote JWTs using JSON WebKey sets. We have great OpenID Connect integration. It's really easy to create a Micronaut application and delegate authentication to a service such as Okta or Keycloak or Cognito. My clicker is dying. I told you before that we use BND error for error handler, but you can use problem JSON as well, or add your own. If you are using microservices, you probably want to use tracing. We have integration with Jaeger and Zipkin, and we are working on supporting open tracing. If you are working with microservices and you need service discovery with a great integration with Consul, in AWS we have also integration with Route 53. I showed you in the demo that routing, you typically use the annotations at controller, at get, at post. But if your company needs to use JAX-RS, you can use that. We have an optional module called Micronaut JAX-RS, which allows you to use the JAX-RS annotations. A JAX-RS resource in Micronaut will be a singleton. That's probably a difference from the specification. but you can use the Jack size annotation, and actually we see quite many users using that. We have many more modules. We have around 50 modules. We have a module, for example, to send emails. You can send emails using SendGrid, simple email service, a great Kubernetes module. We have gRPC module. We have also the concept of endpoints. We have a micrometer. We have many resources, and I am running out of time. So if anyone have any question. Sorry? OK. Why should I start using Micronaut while for years I use Spring with a Spring Boot? So if you are using Spring, the learning curve will be small. The core developers on Micronaut, we were Spring Boot developers. So we were working on Grails, which is a framework built on top of Spring Boot. So we actually love Spring. So we think Spring brought many things, nice things, which we all enjoyed. But Spring was developed many years ago with different constraints that we currently have. What you will see is that developing with Micronaut, you will see like your applications will be much faster. The test will execute much faster. And the applications will typically start faster, consume much less memory, and it will integrate also really well with GraalVM. So my recommendation is try it out. You'll see that the learning curve is quite smooth for Spring developers, because we were all Spring developers, so we like many things from Spring. What is the main reason to create Micronaut? So the main reason to create Micronaut is that the Java frameworks that were built a decade ago, such as Grails, Spring Boot, they were not longer a fit for the scenarios that we have right now. So we have scenarios such as Lambda, where you need like a small application which start fast, which consume few resources, also for containers, or for microservices. So we need like lighter applications and faster applications. So that's the reason. What would you say is the most important selling point for Micronaut that make it stand among similar frameworks? So I would say is probably the fast, low memory consumption, and quite generic. So if you compare, and I think we have many good things such as great documentation, a great development learning curve. We are kind of a more broad framework than other frameworks. Have you tried measure an energy footprint benchmark, compare Micronaut versus Spring Boot versus Python versus Rust? So I have not compared versus Python versus Rust. We have some blog posts about Micronaut versus Spring versus Quarkus. My recommendation here is, so I can point you to the blog post, but my recommendation here is try it for yourself, because in this framework works, sometimes the benchmarks, they are a bit deceiving. So sometimes we are all like trying to optimize for a hello world scenario, which is not really the scenario that we'll have in our applications. I've read that Micronaut is a good choice for cloud-native apps. Is that true? Why in compared to more popular solutions like a Spring Framework, for example? So I would say is because when you work with Lambda, you have a problem which is, and other serverless technologies, which is called startups. So when you deploy a Java function to Lambda, the JVM has to start, then they have to initialize your function, which typically means initialize the dependency injection engine and the whole thing. So the faster the framework is, and the smaller the jar is, the more viable is for celebs. Spring Boot was not built for those scenarios. Can you do field injection with private field? You cannot. So that's good catch. If you saw that, so you cannot use AOP with private fields or with private methods for that reason. Micronaut have one nice thing, which is we have quite a good feedback loop. So we will tell you if you try to add an annotation and a transaction or things like that in a private method. At build time, you will show an exception, and we will tell you. How does it look in regards with integration with other technologies? Do we have some kind of plugins, modules, or do we need to integrate that to ourselves? Let me show you the modules, because it's quite, so as I said, the framework is already quite mature. We have been developing the framework for 4 years already. So we have many, many, many integrations. But you can, of course, build your own library if you want. So if you go to, let me see, before I forget, so that the phone doesn't block. So you go to user documentation. The first thing that you will see is the documentation, the main documentation. But then you have all of these are integrations that we already have. So we have many, many integrations for almost anything you can imagine. So more to come. In Micronaut 3.5, for example, we are going to debut integration with MicroStream, which is a serialization, a persistent engine, open source persistent engine from a company in Germany. This framework has potential to support Java-written CLI tools. Absolutely. The Micronaut CLI is built with Micronaut. We integrate with Pico-CLI, and you can write command line applications. So I saw you today building a REST API, but Micronaut is a foundation technology. You can build, I know it sounds cliche, but you can build any kind of application that you want. We have, for example, a tutorial of writing a command, let me show you that tutorial for you. We have a tutorial to write a command line application, for example, to generate password rotation. So we integrate with this thing called Pico-CLI. I don't find the tutorial, but we have it there. And you can essentially write for example, let me show you an example of a command line application. I have an application which I use to report hours in my company. And essentially goes through all the GitHub repositories in the Micronaut organization and pulls the activity. So this is a CLI application written in Micronaut, which uses dependency injection here. So I'm injecting actually an HTTP client to pull the GitHub API. So yeah, any kind of, I write a lot of these command line applications to, I think I answered wrong, to do any kind of this stuff. But yeah, Micronaut is really exciting in these scenarios where typically Java was not, such as serverless, such as command line applications. But you can build monoliths, you can build microservices. So that the technology is kind of a foundation technology, and then it's up to you what you want to build. I think I answered them all. Are there any other questions, someone? So thank you all.